Yes, hi there, I'm back today with some stuff about for each and where, and sort of a shorthand notation on how you can loop as well, but and some caveats as well with that. Very short agenda, and I don't think the video will be long either. But, we'll dig in a little bit in the array.foreach, the array.where. What happens under the hood basically, so I'll show you that as well, and the speed difference in the loops. I already gave a couple of videos on where the for eaches differ from each other, memory wise, performance wise, and such, and also why. And in this video we're gonna examine that also a little bit, so what's really happening under the hood, so to speak. Yeah, so let's go to an empty editor. And we're going to work with an array, right? So we need to store something first to work with an array. So let's create a variable called all. And what we'll do with that, we do a Get-ChildItem on C. I think Windows would be fine. Windows System32. System32. Let's take that one. Then we do a recursion on that, and we do the ErrorAction SilentlyContinue for now. I don't think I can access everything under System32, some things are shielded most probably, so that's why I do the ErrorAction SilentlyContinue, because otherwise you get a lot of errors printed to the screen, and I'm not really interested in those now. So I run this command, and okay, that was pretty fast. So let's see what we have in all. So now we have an all.count, of course, it's an array, and it has 17,000 items. Fair enough, we can work with that. So So what you can do basically is a for each. See what I did there? For each, and you can do your script stuff inside of there, so to speak. So that's how the for each shorthand notation, so to speak, works. And inside of here, of course, you can just refer to $_ or PS-item, right? That's the current item on the pipeline. And let's see, we just loop through this, and I'm probably gonna break it. See, so that's all the folders and files you got back, so that's as expected, I guess. But you can also do, of course, if you don't want to store it, you can also, of course, get all the items every time, stick that in something, and then you do a for each on that, for each item in items. I didn't want to do that, by the way. For each, and then open and close that one, and then we have a new line, and basically you can do the same. So I can even make it shorter, right? We don't need this all now, so basically we still have our PS-item there now. Item, I said item, yes. So if I run the script now, it takes a little bit, still we have the same output, you see? So that's even the shorter hand. So I'll stick everything inside of this block, so to speak, and then I do a for each on that. So you can do several ways. I'll break this. Yes, perfect. And here we have the same, right? That's if you store it first in a variable. That's the same output. This is just a little bit shorter, but also heavier. Here you need to store it once, so to speak, and then you can comment it out and then play with that output all the time. Like here, you already have it in memory, so you can play a little bit with it. If you do go for this approach on line 3, you are really operating heavy on the file system, because every time you run inside of your loop, you're basically getting those child items again in memory, and then you do a for each on them. And with this first approach, you first store them in all, and then you loop through them, and you can do that several times, of course, and you don't need to get the items again from the file system. Imagine you're working with the file system, you have millions of files, and even you get them remotely. Then certainly first store them, perhaps even in bunches, in stacks of 100,000 or something like that. I don't know. But don't use this approach, because when it fails, you need to get those items over and over again. It's really heavy operation. Just show you that it's possible as well. I'll leave it in for the demo, perhaps. Some people like that. So fair enough. So we can do this. I showed you that, and for each item, for instance, we can also, I think it has a full name property, full name, because it's a file. Let's see if we run this, if that also works. See, now we get the full path back from that for each. Okay, so that was the dot for each. You can also do a where, and I'll show the differences, well, perhaps a little bit. Of course, what we're doing here is basically all pipe to for each object. This is basically what we're doing here, and you can even put that there, and whilst we run that, you should get the same stuff back, so to speak. The performance stuff we're going to dig in a little bit later. Basically, what's going on here with the all.ForEach, that's exactly calling this one. So it's the for each object, and it's the pipeline based looping approach. And I gave a couple of demos on them, and the pipeline looping is very cheap for your system, but it's very slow as well if you handle like a lot of load, and the for each object is not really recommended. So this here, I just give a demo because it's possible, but it's not really recommended for if you need to handle a lot of stuff. If you have like 1,000 items or perhaps a little bit more, it's doable. But otherwise I would skip it and take another looping technology. For instance, you can also do a for each item in all, right? It's our array. And if you open and close that, and then we do $item, right? Not PS item, but item, right? We call it here by a name, so to speak. And then we can do item.fullName, of course. That's again an existing property. And if you run that, you'll see the output here as well. It's all the same, but there are some differences. For instance, this looping technique is not the same than this one. It's really something different. With this technology, I just selected here on 10 versus 12, it's sticking everything on the pipeline one by one and processing them. And with this technology, everything is loaded inside of memory, so to speak, first, and then the loop starts. It's just, and it's a lot quicker as well. I'll show that in a second, that it is quicker. Okay, so that was the for each stuff. And you can also do the same for where. So we had this all. You can also do a where on that, and then you can open and close that, and do some script blocks on that. Then the where, and then we can do ps item dot full name. I think that's supported. Match Windows. I don't know if we get something back. Just the where operator. Let's see if that works. Yeah, see. So everything that's in the full name Windows. So we get that back, and that makes sense because we're querying the Windows folder. I'll try to break this. So that's where. Where is filtering for each. It's both sort of looping, but here with where you really filter out only the results you want. And normally, of course, you don't echo that to the screen, but you save that in a variable, of course, something like that. And then you store your results there. And basically, if you do this, you will see it instantly done. Did you see the speed on that? I'll show you what's inside of T. 17,107 items. If you do the same on, we do that later. It's fine for now. And basically what we're doing here with the all.Where is exactly the same as all pipe to, I said pipe to where object. And then we can do it several ways. We can even copy that over. Like that, and then see, get the same results as you get here. So it's sort of what you prefer. Perhaps if you are lazy, you can create an array and then do a .where on it, because it's, you know, it's a little bit shorter than this. So yeah, but apart from that, there's no difference. It's exactly the same what's going on under the hood. It's the same speed as well. And talking about speed, I'm going to demonstrate the differences in speed, and I'll do that in a second. Let me check this. Yeah, first let me size up our test a little bit to take everything from the whole Windows folder minus Recurse and see how much items we get back, and we're gonna play with those items. And I'll probably pause the video because I think it will take some time. Okay, we have something back, so let's see if we do all.count, for instance. Let's see, so 435,664 items to work with, so we can do some measurements on that for sure. I will comment this out for a little bit. You don't need this, you can retype that again if needed, so stick that inside of that block. If the editor wants to work with me, yes it does. So and now we move this all this rubbish a little bit out of our vision, so to speak, so we're not bothered by that. And I prepared a couple of commands because perhaps I'm lazy, I don't know. So I will paste them in. So first of all, we're going to do a measure command on the ForEach-Object. And we're not doing anything with the object, we're just iterating through all the items, and you see it's an empty script block here, so nothing is happening there, it doesn't matter. And we select the total amount of seconds that operation takes. So I'll create a screen here down, and I'll run this by pressing F8 on that line. Measure command, so now this is running, and it took 3.87 seconds. Okay, now we do this approach, so we do all.Where, and also in this script block we don't do any operations on the where operator, not needed, we don't need to filter, just want to see how long that takes. Okay, so we do F8 there, and just see the difference there, so that was 4 seconds. Sort of the same, 3.8 versus 4, so that's not bad. I clear the screen a little bit and we run them after each other, so we have like a sort of overview there, so run that again. First the for each and then it's the where. Perfect, around the same, around 4 seconds, so that's a nice baseline. And that brings us to the next one, and I'll show that. So stick this one inside of here. We do the same, a measure command for each item in all. Select total seconds. It's a different looping mechanism, so just see the difference. 0.5 seconds. Did you see the difference? It's for each item in item. We're basically doing the same here on this line, for each. Then we're doing on line 3 on that for each. Still there's a huge performance difference, and I'll demonstrate that again by commenting that one out and only running these two. Then you'll see the first one is the all.ForEach method, right, using the pipeline, and the second one is the one that's using memory based looping, right? Did you see the difference there? 4 seconds versus 0.48, so that's like 8 times as fast. And that's really the case. That's really the case. So we'll take another example on looping, and this is based on the count. So for I is 0, I less than the whole array.count. So we loop until that we reach the last number in the array, and we add one number to I, and then start the loop again. And inside of the script blocks, we don't do anything again, but we only capture the amount of time. So let's run that. 1.6 seconds. It's interesting, right? So let's run them after each other once more. You will see that it's quite consistent, the speed difference. It's not like momentum or so to speak. You see, again, so the first one, this one for each, all.ForEach, 4 seconds. This one almost 8 times as quick, and this one, the for I, is also like at least 3 times as fast, or 2.5 times faster than this looping for each method. Let's see, yeah, let's do this one. Don't think we did that one, no. That honestly belongs down here, we do it there. And this is a measure command all, and then where. And I think we need to be fair there. We need to do a .where, because that's what we want to compare, right? A .where, and perhaps the other one we do that afterwards as well. So we do this one, all.Where. Let's see, 4 seconds, and let's make this example where object, because that's the full name, so to speak. And then we select the total, and officially this is select object, of course, but I'm just using an alias for that. And now we run the where object here, and it should, of course, have the same time as this, because it's using the same technology, so to speak. So let's see, we run them after each other and see if we have like the same time. Needs to be a little bit consistent, of course. And you see already that it's there's a huge difference in speed there, so that's very interesting. So a .where, that takes, hang on, 4 seconds. And this one, this all, and we pipe it to where object, sort of doing the same. Let's see how long that takes. Let's see, really interesting this. I haven't measured this before, so really interesting result. And I commented this out, by the way, because I already all.Where I already had this one, so I'll remove it from there. I'll move this one up a little bit. So it's interesting that this one on line 5 is a lot slower than this one, because I honestly thought that was sort of using the same as the ForEach, right? If I do the ForEach, it is consistent, or it looks consistent. Perhaps we can do a nice test on that, because I think so we can do a pipe to ForEach-Object, and then we need to move that, because that will be the correct syntax. And for where object we need to do the same, and perhaps that was where our difference came from, by the way. So let's see if that's the case. This one still takes 11 seconds. Yeah, still 11 seconds, so that's quite consistent. And this one, the on line 5, the all.Where, let's take that one. And let's see, and that's 3 seconds. So honestly, whenever you want to use a where operator on a PowerShell, I think this is the way to go with your sort of everything that's inside of your array with the .where, and then do your magic, so to speak, because it's honestly it's a lot faster than this one. This is using the pipeline-based approach, and I thought this one was using that as well, but it does not seem to be the case. And let's see if those ones, so this on line 3 and 4, if those produce sort of the same timing results. Let's see. I'm curious about this. Yeah, so there's also a little bit of a difference there. So, and I'm gonna do that again. The first one was 4 seconds, so this .ForEach, and I honestly thought that was using the pipeline based approach. But I have some doubts now, seeing the differences in speed. So that looks, and I will run it again, because I want to see some consistency there, if it's actually the case. Yeah, there we have our result back again. So very interesting. So if you ever want to loop in PowerShell, and you can use the .ForEach that at least prefers on the pipe to the ForEach-Object. But I also showed you that this method, right, this one on line 10, you know, just for each item and item, that looping method, just look at the speed, 0.5 seconds. There's no looping mechanism that can beat that. I will do this one based on the count, is also fast, you see, 1.6, also very fast. So still preferable as always, looping with line 10 or 11, those are the preferable looping methods. I did not change my mind on creating this video. But very interesting that we see some differences here in the where object and the .where. There is really a difference, and so let's clear the screen again and just measure that again. So the where compared to the where object. So we run that again. Yeah, extremely interesting. So quite consistent. So it looks like this .where is a lot faster than WhereObject. So it, I would eliminate this inside of my scripts. This one I already never used. This one is nice. It's pretty cool. It's pretty quick as well. But still, those ones prefer. Those are the fastest. And I will give one more demo with all of them after each other and display some nice output. So hang on. Let's just create that on the fly. So we can do minus expand property here on the total amount of seconds. And let's see what kind of output that gives. Only the seconds, I hope, because we want to store that, so to speak. Yes. So now basically what you can do is do result. I do res this time. I'm very lazy today, I guess. I will do that here as well. So you do their res and their res. Just a variable. We're reusing the variable basically. So, and I will explain what's happening as well. I want to do one more thing. Right, output, and then we do. I need to check. This is the all.ForEach. Okay, I'll just call it like this. So the all.ForEach took res. It makes no sense. Basically, res is the total amount of seconds I get back from this command. That is the result, and I'll stick the result in there. And what we can do now is sort of copy and paste that over because I'm lazy, and then we do the ForEach-Object. Took that amount of seconds, and then we check on this guy on the all.Where. all.Where, and then we do that again here for the where object, and then we get like a nice result there. And we run that a couple of times. Hang on. So where object, and then we have a couple of more to do, the really fast ones. I'm going to extend it perhaps to query some more files even on my file system, you know, to make it a little bit heavier. Let's see if it comes to that. So this is item in all, so for each item in items, just call it like that. And then we have the last one, that is for I. Just call it that, for I. See it based on a count loop. And let's structure this a little bit. Yeah, so it looks a little bit better, and then this one as well. And I will comment this out. I don't want to get the files every time for my file system, you know, I already have them in memory in that all variable. So I will comment that out, and I'll save the script, and let's see, and just run it, and let's see what kind of output we get here below. Let's see. Let's run that. .4 seconds for the .ForEach. And then the ForEach-Object was 6.52 seconds. Okay, the all.Where took 4 seconds. And you see there's some different formatting here already, you know. That looks a little bit ugly if you ask me. I know why as well, of course. So we're going to fix that. And again, you see like the last ones were very fast. So we expand the property here. I forgot to do that. Of course, I can write a function that does this for us. You know, we're repeating ourselves. I never repeat myself in code. If I repeat myself, then I'd rather write some functions for that, or a module. But it's beside the scope of this demo. I'm demonstrating the ForEach and where differences. So I run it again, and I clear the screen here. So we should have some nicer output there. I hope at least. It will still be a little bit noisy, but let's have a look. I won't pause the video. The all.ForEach 4.4 seconds again. It's quite consistent. The ForEach-Object 6.55 seconds. Also a little bit slower. We already detected that. The all.Where 4.4. Exactly the same as the ForEach, by the way. It's interesting. And now that was the where object, 11 seconds. And then you saw the for each item in item, right? This one, see, 0.5 seconds. And then the for I 1.6. So the for each and the for I win, of course. But here we have some differences, and this one is a huge difference here. And I promised you to. So let's do my recurse. I will always do minus directory. I think you can do it. Yeah, I only get the directories from my whole C drive with recursion, and then we're going to loop through that once more, and I think we're done then. So let's first store this first line. Yeah. So we have some results there. So all.count 117,500. So that's perhaps not even that much. So perhaps I'll stick everything inside of my C drive in there. But first, let's run the script. Let's see if we see some different output. I'll clear this, remove some noisiness. Let's run it. 1 second, 2 seconds. So we have a little bit smaller loop now. So it's not more, it's less. So let me fix that and pause the video as well. So we're going to do the whole C drive, and not only directories but everything. So also files, and I will pause the video now. Okay, we have something back. So let's do all.count on that again. 515,000. Okay, I guess my C drive doesn't have more than that. So that's the stuff we need to work with for now. So let's run everything again, and let's see the speed differences one more on the for eaches and the wheres. There we go. 5.89 seconds, the dot for each. That was the for each object on the pipeline, 9.05 seconds. The all.Where, 6.4 seconds. And as you can see, the where object was 16 seconds. And then the for each item in items, 0.6 seconds. Again, you see the difference between all of them. It's pretty insane, the difference. And this last one, based on the count of the array, you know, if you loop like that, that is fast as well, 2.23 seconds. So yeah, I guess I've proven again differences in looping technologies or techniques, and the speed differences on that. Perhaps it can be interesting to note that it also has like an impact on your memory performance. I don't like to make long videos, so I do it very short. I try to draw it a little bit, the pipeline, so to speak. So for instance, you have a command here, and that's our Get-ChildItem. Get-ChildItem, that produces some output, and you can put that on the pipeline, right? The pipeline, and then you do that to where, right? And then that's where object, and then you open your bracket, so to speak, and here goes your script, so to speak, the magic in your where operator. And what happens in every item that gets handled here gets handled one by one. So every time it gets set up in the pipeline, it proceeds the whole where operation on that object, and then it sticks the next item on the pipeline and proceeds the whole pipeline. And there's just some overhead there involved. And the same works if you pipe it to for each object. For each objects. Forgive my horrible drawing skills. I think you get the picture. So if you stick something on the pipeline and you pipe it to for each object, the same mechanism goes into action, so to speak, one by one. The whole pipeline gets finished. Even the output is outputted, and then the next one gets set on the pipeline, and again and again. And if you do it on a large number, it will slow down. And how larger the array is that you're working with, the slower the process becomes. At some point, I really noticed that. So very important to be aware of that. Yeah, I think. Let me think of something else, perhaps. Yeah, I think I'm quite satisfied with it. Otherwise, the video becomes way too long. So yeah, array for each, array.where, what happens under the hood, with the ForEach-Object and the where-Object, and the speed differences in loop. There's also differences in memory usage, by the way, and overhead here and there. But I have no time to explain that extra in this video, and I already created a video about that, so you can find it on my channel. So yeah, that comes to a big thank you again, and see you again. Bye bye.